Went live a little early here. Um, Here, let me just start this loop real quick while I finish up a couple last things real quick. Um, yeah, hang on just a second here. I went live just a little early. Hang on, last couple things I have to do. Just another minute here. Um, this is April 27th. This is today's events on the sun. Okay, I want you to watch really closely. There's a big object with a bunch of moons. Okay, Nemesis and its little system just made a pass by the sun and some other kind of object in the lower part here that I'll just let you guys use your imagination on that one. It's kind of hard to describe what I see in there. Huh. Excuse me. All right, hang on just a sec. I'll be right back. Dang it. Hang on. I'm trying to go live on that thing. Get off my back. Press stop my permission, asshole. Not fucking funny. Okay. Sorry, folks, but I don't get much time. I had to cram something to eat in during Dutch's report there, and then I like to have a cigarette after I eat. And sorry, that was just a brief moment there. Okay, on to tonight's long and important report. No intro, no devastating scenes, because the devastating scenes are on the instruments tonight. So let's just start here. Okay, boom. You can see all of our little objects coming out. Okay, boom, 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 boom. There's all kinds of little moons going with it. One's coming off on the other side as well. Moons of this bigger object interfacing with the sun prior to the big one. Okay. Then here comes the big one. You can see this all stretch out now. And you can see the moons along the side of it. And you see how it spread the sun. All this flow from down here to up here is all reaching around the bigger object that's out off of the screen here to the left. Okay. Now, that is weird. I don't know what to say about that. But you can see all these other little moons flying off at different angles and stuff, okay? Now what I want to do is take you back in time a little bit. Whoops, really, cat? Right now? To September 10th of 2017. This is 13 days before the revelation sign. You're looking at Nibiru right here. Here's a plasma wing coming off on this side, and if you tilt your head to the right a little bit, you'll see one coming off underneath that side over there. As foretold in the Bible, the dragon appeared before the woman 13 days. Let me let the cat out. I'll be right back. Always something. Come on, cat. Really, man? I told you we're going to battle. Go ahead. Out. You're not ready. I am in the middle of something. You will have to wait. Now, where was I? Oh, yes, Nibiru. This event happened 13 days before the Revelation 12 star alignment on September 23rd of 2017. The dragon appeared before the woman. In this video, there is more than just Nibiru.
Here's our object right here. This looks like Nibiru. It's got a wing coming off on this side and a wing coming off on that side. And that's not all, because behind that is this big object right here. This is what's causing our flares. Here's a conduit of plasma that is sucking off of our sun, going into this planet. Here's a damage ring or an impact zone on this planet right here. You can see Nibiru sticking out in front of it here.
Okay, I'm going to freeze frame that image. I'm going to zoom it in a little bit bigger so you guys can see. This is our big object, Nemesis, okay? It's a stellar core. It's a burned out core of a star that was way bigger than our sun, Okay? The core of the star itself is 5 to 10 times bigger than our sun. It matches the definition of a black hole. A black hole is not a hole in the fabric of time and space. A black hole is a super dense stellar core so massive in size that it absorbs light. Its gravity and its magnetic field, it's so depleted of electrons, protons, or any kind of photons. It used to burn, it wants to burn again, so it's sucking material from a burning star into it to reignite. This is Nemesis, okay? Can you see it? You know what? Don't make me bust out the... Alright, I'm busting it out. Okay. Clear off some of this here. Oh, man. This right here. Sorry. I'm trying to get the lighting right. This is a picture that I drew while in prison of our Nemesis sucking material off the sun. The material hits the surface and spreads out in a circular fashion. This circle right here is an impact zone. This whole yellow area, oh man, come on, lighting. Right now is not the time. Alright, I'll just do my best. Alright. This is the impact zone. This is plasma hitting the surface and spreading out around this object, okay? Here's Nibiru out in front with this little plasma wings. This is energy, this is material being sucked off of this back into the bigger core behind it. This is another stellar core out in front of it that has material that's being stripped off and pulled back towards this thing. That gives it the wings. Then when a CME electrifies everything, these plasma wings glow. Okay, and they glow like this. Okay. Can you see Nibiru now? It's a black stellar core right here. Okay. It's got plasma going around it. Can you see the plasma around the edges of this now? Let's tint it out a little bit. There. There we go. Let's bring it in closer. Okay, now can you guys see this plasma wing draping back towards it? There's one on the other side. They almost look like little curved horns. Almost looks like a horned planet than a winged planet. Then, right behind it is Nemesis. Okay? Hopefully you guys can see this. The date down here is just so important. September 10th, the day before 9/11. September 10th of 2017. This is 13 days before the Revelation 12 star alignment that happened on September 23rd of 2017. Everybody witnessed the star alignment. They all saw the woman, but everyone missed the dragon. They were all waiting for the dragon to happen afterwards, because when you read the Revelation, it makes it sound like it happens afterwards. But if you interpret it instead of reading it, it says the dragon appeared before the woman, in front of the woman. 13 days before, 13 days in front of the woman. Get it? Got it? Good. That is your Nemesis in Nibiru. Okay? Now, as we pull back from that, I want you to come over here, and we're going to start. Yes, thank you. We're going to start that, and I have to step away for a minute while you guys watch Nemesis and Nibiru and all these other stellar cores pass by the sun and pull another huge plasma event off of our sun. Okay, so you guys just sit there and look at that for a minute. I'll be right back. I got something to take care of. Well, you guys. Oh, I'll just throw you all over the place. How about that? All right, stay right there. It's on the highest setting, so go easy. But take as long of a rip as you want. I'll probably see you later. And then don't forget Kenny. Okay, that was one thing. What the? I'm thinking he didn't text me back. He didn't text me back. Okay, so I'm probably just gonna text him tomorrow. Be like, hey, because he said something about him coming to me at work because he just wants to chat and give me some work stuff or whatever. So what I'm thinking is just like say, hey, I'll let you know my lunch is gonna be from here to here on this day. You can come here because he already offered to come to work. So. Alright, for sure.
Touch base with you in a little bit.
Yeah, well,
I gotta go.
He's on the clock. He calls at 5.
Alright.
Also, it's tomorrow's Friday. It's the last day.
Yeah, I know. We gotta get it done tomorrow.
All right. I'm coming, folks. Hang on. Life happens sometimes too in the middle of the broadcast. So you guys know me. I know what happens. So thank you for your patience and tolerance and acceptance. So are you guys watching this here? Let's slow this down. I'm sure you saw enough of it already. Boom. All the little moons and everything that are accompanying it. And it had just made it past, 7 or 8 days ago. I was trying to find that one. Remember, it snuck past us just a few days ago. So it's making quicker and quicker loops, or more and more passes. You know what I'm saying? The frequency of these events is picking up. Okay, which is not good because it's hurtling stuff towards our planet. All right? And we are at a point where we can't handle any more. We can't handle the slightest little bit. And here comes a bunch more. So I'm going to have to cut over to this instrument now. All right, come on now, please. Oh, thank you. Wow. This is, you know, we were just looking at this graph the other day, and I was reporting on how flatlined the sun looked, right? Right? Was I not saying how quiet the sun looked and looked like it was getting weak? And now here we have all this activity during this weak sun. Why is the sun popping off all this stuff, right? Well, because there's objects doing it. Boom, here's our big one. It dropped way below the seafloor after that. That's what's scary, is the sun is reacting after these events. It's it's not too healthy after them. You know, the sun's getting weak. These things should be popping off big old X flares, and it can barely squeeze out an M now. I mean, that's Nibiru and Nemesis coincide the sun, and it only pops off a small M class flare. Sorry. Now you see this activity already today, and we're diving back down below the seafloor. Okay. Um. Let's back out of this a little bit here. Okay. There's still no reporting on our current G5 solar storm. This does not look updated as to what is hitting us right now. I believe that there might be a delay in the information right now because of what's going on. And let me just take you really quick over to what's going on. Today, Friday, April 28th, 2023, record-breaking massive solar G5 severe storm happening now, still underway. This has been going on most of the day, and even now, it's still going. Okay? These are not reporting it. This whole site is not showing. Look, where's our event? Just seems kind of missing, you know what I'm saying? So I'll be watching these closely to see here they're even talking. An eruption in the northern quadrant early Thursday morning hurled a coronal mass ejection into space. So far, it appears to be headed mostly away from the Earth, but more updates regarding this event whenever necessary. Okay, so we go over to the tracker. We see that, yes, indeed, it is going. It's not totally Earth directed, but watch. It clips it just a little bit. Here's the Earth right here, this little yellow dot. Come on, instrument, let's go. All right, even though that shock wave is coming off to the side, that's good that it's not full on straight at us, but we're already taking ones. All right, this object is still going in this direction. The CME came off at the side as it passed by. Okay, so it's coming right behind us. It's going to go probably right behind stereo A. It's going to pass like this. Boom. Probably go out, loop, and come back around again. Sorry, coughing into the microphone. So, let me back out of there. Now, what I'm a little disappointed with is this also. There should be a big fat layer going on right now. So I'll be watching this closely for an update. And I know that we are having this storm because I can go back 3 days. Look, today is the 20th, now it's the 28th, but it was the 27th today. So let's go back 3 days, which would put it at the 24th, right? Let's go click on the 24th, and you'll see the energy that came off the sun on the 24th that's hitting us today. See this? That caused our G5 magnetic storm that we're having right now, that object. And all of this, remember this a couple of days ago? This is all the energy that's coming, that hit us today. Remember, this is 3 days ago. It takes about 3 days for this stuff to get here. Okay? Now, do you see how this stuff is traveling south? This one off, right? Boom. These are traveling south and under the Earth, right? So we're going to come over here to the our vortex. Okay? Our polar vortex. Our whatever kind of weak-ass, backward rotating polar vortex. I want you to look at the top of the planet. This right here, where my little marker is the the geographic North Pole. Okay, our vortex should be rotating around up here, right? We are in transition season, so we do have disruptions in our polar vortex. But this is a different disruption. This is rotating backwards. It's off kilter. It's off to the side. Look, right up here is the top of the Earth. Here's where the vortex is centered. Okay, so we have a shifted backward rotating weak polar vortex. Okay, that one object that's going to the north. Now, let's go take a peek at the bottom, shall we? Wow, look at this. Why is this so super organized? Maybe it's those 4 objects to the south. Do you see it? Here's your 4 objects creating this nice, big, strong polar vortex at the south. Then we have all that magnetic power is fighting the one single object that was traveling by the north. It's probably rotating backwards. And these things are magnetically attaching themselves to the planet and causing our weather events. Okay? It's not too tough to figure out. It's really not that hard. But I am showing you our objects and what they do when they pass the Earth. Okay? See? I've been showing you guys this the whole time. Okay? So, whoa, that's a trip. Take some acid and play with this thing, huh? Whoa, no way. Here we go. Here we go with our vortex over China here. Now this is breaking through the blue boundary. Do you see what I'm saying? Here's our blue boundary where the southern equatorial flow separates and goes different directions from the upper, right? See, they take different directions. The upper goes a different direction, and that's natural flow. This is the boundary line, okay? As we pull over, look at this, is crossing the boundary line, circulating back up right over China, okay? There's something going on there. All right. This instrument, invaluable because now we can drop down another layer and go to our upper jet stream. Now this is what kind of steers our weather, okay? It's not the polar vortexes that steer it, but the polar vortexes affect the upper jet, which does steer it. So, as we go in deeper here over California, look how high and intense this trough is, going way up north, going way up into Alaska, taking cold air, bringing it right over the center of the country, mixing it with what? The moist, warm air coming off the Gulf, and I'm going to show you that here in a little bit on Venture Sky. This hot water right here, okay? It's like a freaking hot tub. And we have all the oceans heating up drastically. Hopefully some of you saw Mike from Around the World tonight, and you were taking notes and paying attention. I think it all made sense to my viewers who see what's going on and listen closely. It all makes sense to them. Anyway, back to where we are. This is where our cocktail's being mixed right here, okay? This is no joke. This is very serious. Okay, and with that, keep that on the back burner in your mind, okay? Because this is going to come into play later. All right, so keep that on the back burner in your mind. We are multifaceted here. We do multiple things on multiple levels at multiple dimensions with multiple meanings. Okay? Let me take the winds off first. See what's going on with the country? You see how all this is all SO2. You guys have been here for a while. This is all SO2. You know that. Maybe newcomers, you're getting used to it. This is the gas that surrounds the magma down below being pushed up first before the magma gets there. Okay? Before the magma gets there. Because we just keep expanding and expanding from the inside out. We're overcooking, we're hard boiling an egg and overcooking it, cracking the shell. Period. It's not too tough to figure out. Here is a crack, and this is where that SO2, the rotten egg, is seeping out. Right? Rotten egg seeping out. Right over the Bay Area here, okay? This plume is grown towards the Central Valley. It's kind of stretching down more in California. It used to be just one little dot here. Now it has grown, okay? Sorry. Here's another plume down here, okay? And then as we do our earthquake report later on, this will come into play, okay? So I got you guys thinking multiple things with multiple going on, all right? I want you to come up here at BC with me and see this plume up here that's going off up there. We also have these volcanoes running down cascades here, and you see little plumes going off at them. That's because our inbound energy has charged the core is heating up, and I bet we're going to see a screeching event starting like right now or real soon. Okay? You can see how this gas gets caught up in the storms, okay? These are sulfur storms, folks. For lack of a better term. They're sulfuric rain, acid snow. Our storms are no longer normal anymore, folks. Okay? You're looking at China emitting a bunch of gas because there's a lot of pressure underneath this area. They have something going on that's much deeper that I talk about. We're not doing that tonight. We are going to the island of Java, and you see how purple it is, right? And you see this little canal right here in between the islands. Bring this over and center it for you. Okay? This is the canal in between these two islands. This is where Nat Krakatau is. Okay? This is one of the most dangerous volcanoes that just went off not too long ago. Remember the big blast? Right next to it is this pressure being released. This is a very sensitive area. There's a volcano going off here already. All right? This island is in very dire straits. We need to watch it carefully, pray for it. Pray for all these people. Pray for endurance for each other, okay? That's what you really should be praying for, is endurance for each other. Pray for my endurance. I pray for yours. I need the endurance. I am under attack in a way that you cannot even imagine. We got to go. So we're going around the world and we're praying for each other's endurance, okay? I'm going to go into South America here a little bit. You see all these independent sites, okay? I always zoom in on this so you guys can see. These are all individual sites. Okay, this was a big deal a long time ago when there's 4 of these dots off the west coast. Now there are millions of them and no one's screaming anything. I could be screaming right now. I am doing everything I can to maintain my composure and put a friendly smile to this. Here's Jamaica, all right? It's caught an issue. Cuba, all right? Mexico's starting to have an issue, okay? The only place we're quiet here on the west coast, everything kind of west of that line seems to be faring okay. Everything east of that line, yeah. And you can see the weather is flowing this way too. Believe it or not, this pressure and heat underneath might be steering the weather. Okay? Now we're going to back out, and I want to do one more other chemical because this is just not a joke anymore, and I have to go thoroughly. We are at another sulfur compound. This is SO4. It is what I like to call sulfur quad oxide, for lack of a better term. Okay? And SO4 is emitted from the ground as well as a human pollutant. Okay? Regardless of where it's coming from, I want you to look at how much of it is around the planet. The white is super concentrated, okay? This green and yellow area is pretty bad. So the white areas are super concentrated SO4. SO4, keep that in the back of your mind too, okay? I'm writing this stuff down. Okay, you see all these intense plumes of SO4, and then it gets caught up in the weather. See, it gets caught up in the weather, gets dragged across the world. If you look, it has circumnavigated the entire globe now. We have SO4 around the entire planet. Okay? Now, when you look at this, I want you to think about something. When you take SO4, it likes to attach itself to water. Any kind of water that's in the water vapor in the air, water on the ground, any kind of H2O, it will attach itself to and make a compound called H2SO4. That's also known as sulfuric acid. Okay? This SO4 mixes with the water vapor in the storms and it rains sulfuric acid. I'm telling you guys, your rain and your snow is going to be very, very acidic. And the more volcanoes we have going off, the more this is going to increase. Okay? It's just a runaway train now. Okay? Sorry, it's a runaway train. Oh, bio. I want to do one other thing real quick here. Fires. No, I want space on that one. There we go. Looks like maybe our G5 storm is false alarm or I don't know. Don't know which I'm trusting right now. What about gardens, Brian? What about gardens? You should be growing gardens, but you're gonna have to make them portable, like in pots, so you can grow outside during certain times of the day, and then when violent weather comes through, or you need to move your plants. Basically, say if there's marauders coming through your neighborhood and you want to be able to pull your plants, right? Well, put them in pots. That way you can grow your stuff, move it around, set it in the sun, put it in the shade. You're just going to have to be portable. And I would think about maybe a dolly with, you can wheel plants around in pots, big pots, small pots, multi-pots. However, you got to make your garden portable. Because pretty soon the soil won't be conducive. The sunlight won't be as conducive. There'll be certain times when, and you can't. Also, be prepared to cover your windows. All right, guys, maybe cardboard, any leftover cardboard from a refrigerator box or any kind of boxes that you guys got coming in. You might want to save some cardboard and get a lot of duct tape in case we have a sun event where you can't have the sun shining through the windows of your home. Okay? Tin foil, black out some windows if you never look out of them, black spray paint. I'm talking emergency. If you have to do it, all of a sudden we have a bright flash and everybody's like, what the hell was that? And you need to clamp down. I'm saying, you have curtains for all your windows, okay, all stuff like that. I want you to start thinking along those lines too, okay? Just be prepared. There's always things to be preparing for, and let's just say we want to be ready in case we have a really intense hot day, we'll say. We'll call it a hot day, as in like hot particles, okay? And you want to keep those from coming in. Um, I mean, I would suggest lead over all your windows, but you can't do that. So, like a sheet of aluminum foil backed with some cardboard, because the cardboard itself will still heat up and maybe catch on fire. Also, something I was thinking about earlier tonight was skylights. There's been some huge hail, and we are not done. We are going to see even larger hail. Mike was talking about that tonight, and it's about time he does start talking about it, because that is our serious issue that's coming up. We are having tornadoes, yes, and the hail might actually become more dangerous than the tornadoes. And when we get into, we just had 4-inch in diameter hail yesterday, okay? And it was growing in size. These people were holding these huge chunks, okay? We might see 7-inch hail. I want you guys to go look up the world record for the biggest hailstone and start thinking about millions of those falling and just pummeling stuff. At roofs, carports, doesn't matter. It's just going to be, it's going to start getting gnarly. You know, we got the ocean heating up, we got the weather heating up, we got the sun heating up. Okay, all three of those mixed together make for a very dangerous, dangerous cocktail. I got to back up a little bit. We're jumping around a little bit tonight. Let's pop over to the Schumann, because I want to take a peek. See, we have this gap right here. That's just missing data, okay? That concerns me, missing data. I don't want to see any missing data at this point on this instrument. It is just too vital, right? Ooh, what is going on here at the end? Let me zoom. Oh, I can't zoom in on this one. Here, let me pull this closer. Yep, just as I thought. We're starting to have a screech event right here, okay? This is the core and the shell grinding together. While we're on this subject, I was over at Dutch's, okay? And Dutch and I agree on a lot of stuff, okay? Let's just say I understand geophysics a little deeper than he does, and he doesn't understand how the core works. He thinks it's like electromagnetic plasma emitting magically from the middle. Well, no, we have heavy metals that sink deeper and deeper. The heavier the metal, the deeper it sinks. Okay, it's just a law of physics. Our core is iron. It's molten nickel iron, super, super dense. It's probably denser than that. It's probably a material that's not on the periodic table. Okay, because the core of the Earth is so hot that it burps out radioactive material like plutonium and all these other radioactive isotopes. All right, come from the planet itself. Okay, so it's a nuclear furnace down there, and it's the shell and the core rotating inside of each other. It's a big gyro. It's like an electric motor. If you don't have it hooked up to a battery and you just spin the shaft, you will create a magnetic field by those magnets rotating inside of the shell of the motor, right? That creates an electromagnetic field. That's the electromagnetic field that surrounds the Earth. That's what protects us from all the sun and all the bombardment, right? Okay? So what he doesn't understand yet is how the core works. When he does, he will understand his geophysics a lot better. But he's a good man, and I like his earthquake reports, and we will get into that here a little bit better, and a little later, because I wanted to see what he had to say versus what I have to say. Okay? I want you guys to get a little bit of both. Okay? Anyways, as we progress here, sure enough, we have a little screech. This is nothing. This is a little mouse fart right here. It's those big, tall, long, intense ones that go way off the chart that last for a long time. Those are the ones I'm worried about. And this is an indicator of another wave of screeching coming in. We know we have it coming in because the wave just hit us, right? It takes about 6 hours for the wave, or for the energy to hit the core and for the core to expand and start screeching. It used to take about 12 hours, but we are so close shell to core now that any little blast will automatically make it screech within about 6 hours now. And here's our first little hint of a new screeching session coming in. You see these upper lines up? There's some upper lines that kind of scratches that go across this way, and as these start to wind up and getting more intense, you can tell we have an event coming. All right, we had an event. It screeched. We recovered. We probably had an event right here, and then it recovered. Now we're having another event. I think we're missing data, really. This doesn't look like it's totally filled in, but you can see, just like I was about to, say, here's another screeching event, okay? It's not that tough to figure out. Anyways, back to this. Here are all the fires and hotspots, okay? And we have ones that are out of the water. See, wait, these are islands. Good. I don't want to see any out here off the west coast. But we do have them on land, don't we? All around the Bay Area right here. See all that area where I was just telling you? There we go. Sorry about the glare. Deal with it. I have low tech. I wish I had my lab. Ugh. Oh well. I just do it this way, I guess. Yeah, you can see them. There's hot spots. They're there. This is right here. This one, right where my little mouse is, or the arrow is, that's right around the geysers, okay? We have hot spots popping up in the north central valley right now. Look at this going up into the Cascades. Okay? This is coming to life, you guys. There's volcanoes going off all over right now. If you go to the Dr. Astro Geotech that I sent you to, he's been busting out video after video after video, and just so many active volcanoes all charging up and spewing right now that it's alright. Here's China and all its hot spots, okay? I want to come looking down here, okay? Then here's our island of Java. Let's get that up in the shadow there. There we go. Try to tone down this glare. No. Alright. You can see we got these little hot spots going along right here. Okay, this is probably where a volcano is erupting. We have a lot of magma intrusion in this area, right? This one right here by the channel. See this one right here on the edge right there? Let me put it right in there, I think. There we go. Alright, so we have this little line of them right here, and this hot spot right here on the channel, right where we saw all the SO2 coming out of, okay? We're going to be expecting earthquakes right in this area, alright? Of course, because we have all these hot spots, all this pressure, okay? And even this island was starting to get, dark. How do I write about there, I think? Yeah, alright, I want you to come with me offshore here. Come on, put it in the screen here. Oh, it's not picking it up very well. Oh, there's a couple of them you can see, I guess. There's all these hot spots out in the water. What are the hot spots? There's not campfires out in the water. All through up in here. Oh. See? See all these hot spots coming down this peninsula right here and then going into the water. Where else did I see a couple more? Here's Taiwan, I think. Yeah, there's Taiwan. You got some right going right in there. This could be city activity, maybe heat from their little huts, their little fires, maybe because we do have primitive people that still live in these regions that use open fires to cook with, to heat with, to sleep next to as protection, all kinds of great stuff. But a lot of this is not just campfires, and I think you know the difference. My audience has discernment, okay? Alright, let's see over here. It's a populated area, so these probably all stuff. Alright, but I won't pull back. You saw the ones in the water, okay? Oh. What's going on over here? This might be an island over here. That's the one spot right there. Not a big deal. Alright, anyways, that's enough of this instrument, okay? You guys see how I use it? You can come over here. This is earth.nullschool.net, okay? Earth.nullschool, nullschool, nullschool.net. And you can get this instrument. When you get pulled up, it'll say, do you want Tokyo wind or the whole Earth? Well, who wants just Tokyo's wind when you could have the whole Earth, right? So click on the whole Earth. And then you come over to this wonderful little thing here, and you just start playing with it, okay? Maybe one day I'll try to do a tutorial on that. Now we have to move on. Sorry, folks. I'm boring you guys to death, probably, with the most fascinating information. We'll get back to that. Okay, let's just do this forecast real quick. I'm gonna let the loop play. You know the drill, real quick. You see our storm going off here. As you know, let me pull back. I want you guys to get time and date. Update on me right now while I'm doing the stream. Okay, good. It didn't. I think I'm getting time and date, everything in there. It appears to be up in the corner up here. Maybe what are you doing? Okay, here it goes. Yeah, pull back just a little bit more so you get time. Oh, I see what happened. Hang on. Stay right there. Alright, now you can see time and date real quick. Alright, yeah, we're gonna have to do a quick report on this. Can't dedicate too much time to this when I want to. All that's gonna change though. I think it's gonna get a lot stronger. I pray that it doesn't, but I see the incoming energy happening at the same time this is congealing and coming together. So I think my audience knows what that means. Okay, we really don't have to predict or forecast anything. We know that we have inbound energy coinciding with this storm at the same time. Okay, so with that in mind, just kind of look at that for a second. I gotta take a quick drag and I will be right back. You guys are so patient. Oh, I think maybe I'm teaching you a little patience too, aren't I? And don't go nowhere because we still got lots to cover. Let's see, that wasn't so bad. It's a good thing I can smoke a cigarette and 2 drags now. Now, where was I? Oh, yeah. Okay, let this loop finish running. Come here. Give me my mouse back. What happened here? There we go. Okay, let this loop finish playing, and we're going to go frame by frame it real quick, right? Wow. Quite the interesting development. All this other stuff we're not really going to cover. We're just going to focus on our one storm. Just take it one at a time. All right. Now, here is our GFS model storm right now with pop-ups in Tennessee and off the coast of South Carolina. A lot of stuff, moisture, looks to have made it off the coast of Florida. Now I'm going to come over to Venture Sky. Come on. I want both of you guys to play nice together. Okay. See? They're playing nice. Here we are, thunderstorms. We got the lifted index pulled up right now, okay? And I want you to look at, the flow asymmetry of the winds taking all this moist, hot water, this moist air over all this hot water, and pushing it up in this direction. All right. Another thing we want to show you too. Do I still have that pulled up? Yes, I do. Okay, we're going to go to the Helicity, the SRH. Now this is the vortex or rotation potential in our moisture, okay? Let me, I'm going to explain this real quick for you guys, okay? We're going to come over here. Sorry, I'm bouncing all over the place. Helicity, okay? It's the property of a moving fluid which represents the potential for helical flow, i.e. flow which follows the pattern of a corkscrew. So it's the property of moving fluid which represents the potential of the pattern of a corkscrew to evolve. Helicity is proportional to the strength of the flow. The amount of the vertical wind shear, that's wind going up, the amount of vertical wind shear, and the amount of turning in the flow, i.e. vorticity, okay? So, helicity is a vorticity, okay? Knowing that, we are going to back up now. Whoops. Back up over here to our helicity. All right, this is the potential for vorticity off the coast here, going here. Now, as we go forward through time here, I want you to note this area back here behind Texas that's forming, okay? We're going to go forward in time now. This will be 5 a.m. Pacific, which is going to be 8 a.m. out here, okay? This is your potential for vorticity, okay? Back here, too. Okay, we're going to go up to, this would be 8 a.m. This will translate into 11 a.m. East Coast time, okay? Do you see now where our helicity has shifted to? Okay, that's in the morning. That's still noontime, basically. 11 a.m. 12 East Coast, or no, 11 a.m. East Coast. Okay, then here's another hour later. No, 3 hours later. Sorry, this will be 2 p.m. Okay, now this is the helicity, all right? Now we're going to go back to where we're now, okay? So we're backing up to current conditions. And we're going to go back to the lifted index, okay? Now this is the lifted index. This is all the hot water, and it's pushing this up here. Remember, we had our helicity. Now as we go through these hours here, you can see this moisture creeping up in there, mixing with the helicity right over this part of the country at 2 p.m. East Coast time. Okay? We're going to go to, this will be 5 p.m. Look at this back here in Houston, or back here in Texas, okay? A lot of this is still lingering in this area, but our shift has now shifted back here. It even erupted back here an hour before. See it, there's 8 a.m. Pacific, 11 a.m. Pacific, now 2 p.m. Pacific, all right? So that translates to 5 p.m. East Coast, all right? This is as convection 2 hours before the peak of convection. Here, this is going to be 8 p.m. Eastern, 6, 7 o'clock Texas time at the end of convection. Right in this whole band from southern Texas all the way up into the northeastern tip of Arkansas. Even the plume kind of reaches still orange up into Missouri, Mississippi, and everything, okay? Now, with that, we're going to go to the radar now. Okay, this is our current radar. Let's go 3 hours ahead. This is 8 a.m. Pacific. Here's 11 a.m. Pacific. This will be here. This is 11 a.m. 2 p.m. East Coast. This will be 5 p.m. and then 8 p.m. All right. Let's go. Wait. Let's go back to the 5 p.m. right about here. Is that the one? Can we pull this down, please? All right. This is a projection model. You see our center of vortex kind of right here, bringing stuff in towards Washington, D.C., okay? Um, 8 p.m., by then it kind of moves out, okay? This is all projection, okay? And we'll still have thunderstorms up in middle of Pennsylvania, heading up into New York still. Okay, this whole line is just going to move right up the East Coast. All right, so now you have all three of them. You have a radar. Okay, you have our thunderstorms with our cape here. I want to see the cape at the. Oh, good. It moved way far south here. Okay, before it was cutting across the middle of Florida here, right at about Tampa, and it looked the southern half of Florida was really gonna get spanked, but it might still happen. Let's at this point here. I want to switch back to radar. There's still this little cell blossoming here that could possibly still cross, but here you can see that they're already off the coast. But that's all. This is all your cape. This is your potential energy, okay? And let's just back out. I want to follow the cape just a bit. Let's go deeper into the day. Where's the end of convection? 2 to 5. Well, this will be right after the end of convection. Right there, and that's what our cape potential will be. as I kind of... All right, these values up here in Georgia, this is a little concerning right here. Southern Georgia right in here, their potential is still really high, and over here in this area up into Texas. Okay, this is all your potential tornado juice right here. Okay. Fair warning for this whole area today in Texas. I'd be on high alert. Corpus Christi, everybody, San Antonio, up. It looks like Dallas might be on the back of the dry line. We'll see as this produces. Let's go backwards just real quick. Oh no, earlier in the day it was up there. Ooh. We're going backwards in time a little bit to when it really first starts. Okay. Here, this is your cape. This is your potential energy, all right? That's 8 a.m. or 7 a.m. probably Texas time. We're going to go 10 a.m. Texas time. So this stuff is going to start blossoming early in the morning, or the potential for the cape is already high. We have high values early in the morning. As we go into the day, it gets deeper into the place. You can see this vorticity up here is actually sucking up all this moist, hot, warm air. We're just going to be hanging out here. You guys got nowhere else to go. You can sit here and chat amongst each other or whatever while I do this. You can see this vortex of this wind, right? It's pulling all this cape up into Texas, okay? We're talking Killeen, Austin, San Antonio, everything west of Acuna to Houston. This whole area at 2 p.m. going now towards Waco. They dodged a bullet. They might not get to dodge it today. This is concerning. So, this will be 4 p.m., 5 p.m. their time. This will be at the end of convection. Convection will probably end right around here, but it won't let me see that. So let's just go right before the end of convection, all right? So that's going to be your producing maximum right before the end of convection, right there. That's all your potential energy for Texas. Then Florida. You know what? This cape, it might as well just go all the way across. Now that I look at this, because you see how much there is all the way around it and up into here. Pretty much from here on down, all of this area has the really high potential, okay? And you see this wind flow coming off and then coming on shore. Okay? That's all your potential energy just flowing right on shore. So watch out Florida today. Watch out Georgia today. All this potential energy by 8 p.m. East Coast time. I want you to look at this really closely. This is 8 p.m. Pacific. 8 p.m. East Coast time. Do you see the Cape potential over Greenville, Jacksonville, Wilmington, reaching up towards Richmond, Raleigh, all of this reaching up to Savannah, back to Albany, Dothan, Tallahassee, expect to see some stuff. Jacksonville, you guys are going to be rocking and rolling today and tonight. Okay, and then it comes up here to this area. So, let's go one more. it's still there at 11 p.m. at night for them. Boom, there's their cape at the end of convection, just before the peak of convection, and then backwards approaching that area throughout the day, okay? So as we go on throughout the day, this cape index is going to reach up into this area, okay? Boom, especially right before the end of convection. So this whole area, just because this doesn't look red right here, I wouldn't count this out. I wouldn't count out any of this area right now, okay? It's just important to know this, okay, and be on high alert, because this is no joke, right? These potentials are there. And I will be watching the storm chasers closely tomorrow. All right, I suggest you guys, if you live in these areas, you watch them closely too. Or if you know people in these areas, you start steering them towards Andy Hill, Ryan Hall, some of these other meteorologists that are tracking these tornadoes and warning towns 5 minutes, 10 minutes down the road, hey, you got something on the ground coming your way. All right, we're trying to save lives here. So it's important that we track this weather, look for it, understand it's how it works, so we can look for it, predict it better, and know what to expect a lot better, and when to hunker down and when not to, when to pray too. Lots of praying. This is kind of unstoppable. So is this. I mean, just pray for mercy that there's not so many lives lost. There'll probably be some lives lost today. Unfortunately, because I just saw a report and this lady had a tornado touchdown on her street today. There was tornado activity today. I should show you some of that later. I had no idea that was happening right across the street from me. What? You had a tornado rip down right down the street in your neighborhood, tearing up your neighbors' houses. And it wasn't until the news crew came over and knocked on your door to ask an interview that you came out and stepped outside and were shocked that a tornado came through? I am seriously shocked at people's just lack of awareness, or I don't know. So it's very dangerous. Let's just say the ignorance level, not being stupid, just ignorant of facts and knowledge, the ignorance level is detrimental to the health. And we got to help these people, right? So that's what we do, is we come over and we say, hey, shit, you want to know what's going on? Go over, Brian will tell you. He'll point this shit out for you the best he can. He'll send you to somebody who knows even better, They're just not on right now to report. These guys are probably sleeping and getting charged up for tomorrow. They know they're going to have a busy day. They probably saw this Cape value and went, oh crap, I'm going to have a long day tomorrow. Okay, these people are going to have a long day tomorrow. So is most of this whole East Coast. Okay, now we got to get away from this one, because it just looks scary, and it should, because this is the lifted index. All right, this is the one that's collaborating with it. Okay, then we're gonna go back and look at helicity, everybody's new favorite word, right? What does helicity mean? The potential for vorticity. Here is your potential for vorticity right around Baltimore, Philadelphia, that whole region. Do you see this? You guys paying attention to what's going on here, right? Good. Because I told you this was coming a while ago. And here it comes. We're witnessing it. And we're just steps away. It's going to happen today. So everybody brace for impact. Now is not a good day to have your head up your ass. Really, it's not. I don't want to hear any reports of somebody coming out of there. Oh, I did not know there was an F5 coming down the street. If there's hail coming down in your yard that is 4 inches in diameter, that means get in underground. There is a tornado coming. Hail is an indicator. Thunder is an indicator. Rain and wind are indicators. Shoot, maybe you should look up into the sky to see if there's any clouds in your sky. It's not too hard to observe the weather, and it's time people stay very observant of their weather. It is very highly active, very conducive, very volatile, and it's on display tomorrow. And we need every prayer we can get. Okay? And just hold on. Now, this is something else I wanted to report on because I'm having a little doubt about this right now. This G5 severe storm supposedly happening. We're going to X out of that for right now. And we got another event going on here. So, if we can get this to... Hello? Cooperation computer. Beautiful image, though. Okay? And that was showing as of a little while ago. Okay? All right. Hey, don't you love technology? Wow. I'm so impressed by AI. Look at the lightning speed. Wow. Anyways, we still have this little event going on. This guy, come over to his channel, pay him a visit, give him a thumbs up and a like, and subscribe. He's doing the best he can to bring you this event on Beetlejuice as well. You see these flare-ups. There's been several events where the screen turned white, purple, all kinds of different inbound kind of energy coming from this star, from Betelgeuse. It's 6.42 or 642.5 light years away. Okay, it's in the constellation Orion. All right, this is mentioned in the Bible. Okay, and here we are at these biblical times, and we got this guy acting up now. All right, see that? See how the screen just went full on white like that? And you can see it pulsating. Let's get true colorization. Well, I'm not getting the best color out of it because of my technique and my stupid screen. But if you come over here to this site, you can enjoy it yourself live, okay? So I'm sending people that way. Give him a thumbs up, subscribe. He does a good job to try to bring you this stuff. He was the one reporting on the G5 as well. So go give them a like and stuff. I want to come back to, where was I? Oh, latest earthquakes. Just last little touch up on the earthquakes here, okay? What is your problem, USGS? All right. So, Dutch's report tonight, he pretended like this was all just one quake. Let me pull this up into the shadow a little bit better for you there. Get it out of the glare. All right, he pretended like this was all just kind of one quake. Now, we're going to go through this meticulously. This is not the first one. I want you to note these times. I'm going to call them off if you can't see them. Nah, just call them off. All right. This was at 2013-51. That's the second quake. It's the 6.6. This one is at 2013-44. Okay, this is our first deep quake. Is a 6.0 at a depth of 592.9 kilometers. All right. Sorry about that, a little alert. Now, that's our first quake. Then, immediately after, okay, note these times. This is 2013-44. This is 2013-51. Okay, two different times, two different quakes, two different magnitudes. This one's even deeper. It's at 598.5. So this one was shallower. This one was deeper. This one was first. This one was second. This was deep, caused a bigger, deeper quake. These are two different quakes. They're not one. They're two different quakes. First one's a 6, second one's 6-6. Do you get it? 666. This is God screaming out loud through the earthquakes like he likes to do, telling you, hey, the devil is here. Earthquakes are happening. All right. The depth. These are 2 deep quakes. What happens when they reach the surface? We get a full magnitude bigger, right? Okay. So a full magnitude bigger than a 6.6 is a 7.6. A full magnitude bigger than a 6 is a 7. So we're talking a 7 and a 7.6. That's just these 2. So let's just be conservative. 7 plus 7.6, potential 8. Okay? Potential 8 at the surface. Combined energies, okay? So, we now have these 5.5 at 2150.06. This 5.5 is at 2034.10. This 5.5 happened before this 5.5 happened. These are 2 different 5.5 deep quakes. This one's at 571. This one is at 569. 2 different depths, very similar depth, but 2 different depths, 2 different times. Both 5.5. 5.5 plus 5.5 is 10.10. No. But do you see how the numbers are kind of coinciding? So we already have 8-ish potential. Add 5.5 plus another 5.5. Let's say 6 potential, right? At the surface. That's being way conservative. 6 and 8. And what's this down here? A 4.8 at a depth of 585. All of these are deep quakes. 8 plus 6 is 14 plus 4.8, 14, 18, almost 19. No, I'm joking. We're not going to have a 19. But what's this up here? Another deep quake, 4.5. Wasn't I saying we're going to have another 4.5? Look, we have 2 5.5s, right? Right, matching ones. We have 4.5 down here, or 4.8, I'm sorry. This is probably our latest one. Yes, it is. Because I remember there being a 4.5 up here earlier, and I was waiting for another 4.5. And that would be this one, but it came in a little stronger. So, 8 plus 6 is 14, plus these 2 at 4.8, 4.5. All right. So, I want to say a number, but before I say a number as to a potential quake at the surface going into the system, right around here, or anywhere now, anywhere at the surface now, that this whole event, this whole cluster right here has happened. See, when you back out, it makes it look like it's just one quake, huh? Oh yeah, just one quake there. No. Look deeper. There's a lot more going on. This is how they bury the information, okay? All right. So, in the chat, as students, let's wait, we got to check this first. That is residual energy already being scrubbed off. No, that was earlier. That was before it. Never mind. So, nothing has really been scrubbed off. Look. What's this? 4.2. That was before all of this. So, as if these weren't here, because these happened before this whole flurry of deep quakes. in the chat, I want you guys to give me your estimate as to what you guys might think. You guys think might be hitting the system right here, our first big quake. What do you think it's going to be? Let's all kind of now, you know, you could be conservative, you could be a little out of the park, but try to use your best guesstimate, your best reasoning, okay, with what I've shown you here. What do you think the potential is that's going to be coming out? 5.5. Okay, that's very conservative. That's good. I would love to see 5.5 just knock all the way out the system and relieve all this pressure. That would be perfect because we don't want to see much above that. But I have a feeling it's going to be a little higher than 5.5 because we already have a 6.6 at a really deep depth. That translates to a full magnitude at the surface. So let's start around 7.5 at least and work our way up from there, because that would be the minimum. And Dutch said a 7.2 in his broadcast, which kind of surprised me because I don't think he's taking into consideration. He only reported it as one deep 6 when there's multiple going on there. Okay, I have a feeling he's kind of just being conservative with his show because he knows what it means. Since I don't see any other guys, there's 39 people watching right now. Get your ass in the chat and put a freaking number in there. Be brave. Just a good guess. We're already 6.6 at least at depth. 7.5 to 7.6 at least at the surface. We have all these combined together. If you watch Dutch, he adds the other ones onto the tail. He'll give you a 0.5 plus a 0.5 brings it up another full magnitude, plus another 0.5 and another 0.5 brings it up another full magnitude. These two will be together as a combined thing, plus the two other full magnitudes. We are talking the potential for a 9.0 to a 9.7 or 10 hitting the system. And it got real quiet after this. I would love to see just a 7.6. That would be beautiful. But I think we are going to see something much larger because it hasn't popped off at the surface yet. All these deep quakes have yet to produce a surface quake in the system yet. I'm putting this whole region on super duper high alert for a 9.0 or greater tsunami alert for the whole Pacific Rim. Over here, we got new activity right here, 4.4 on the Cocoa plate, or just off the Cocoa plate, Cocos plate there. Here's one on the ridge, or on the fault line, 4.5. We have activity up in Texas already happening. Boom. 2.6. We have activity down here at SoCal already happening. Yeah, kind of. No. Nope, not at all. Nope, there is no energy has made it around the corner yet. This is all residual from the other day. Okay, these 3.1s, remember how we had 3s? It came in as 5 energy, got pinched off, and then resulted as a series of 3s coming down. That's the tail end of that energy right there. See how quiet it is right here? There's a bunch of energy coming into the system. This 4.5, that's just residual energy from the last wave that came through here. Remember, it dumped off all these 4.5 mid-range 4s along the way. Okay, boom, boom, boom. That's all that last wave energy moving through. Here's another one. Okay. You see how it went up through the system? Came up here, boom. Remember, it got pinched off. Came across over here. Came down, resulted as 3.1s. Now it made it down to here. Okay. This is possible result, just a little bit of energy from the wave before. Okay. Yeah, I don't see anything yet being scrubbed off. Give me this. Ooh, wait a second. Nope. No, it's a 5.0 at a depth of 10. I thought maybe that would be a shift on the other side of the plate, because this whole plate probably moved. That's not it. That's more energy being scrubbed off from the last wave. Okay, so unfortunately, you just watched it. I searched around. Okay, we do not have any energy that is yet to be scrubbed off of this. All right, I'm talking. We are about to have a major quake in this area. Tsunami alert too. Okay, all at the same time we got this storm hitting up here. All at the same time we got this inbound energy coming. Right. Boom. This is the 24th. That's what hit us today. Oh, here, let's go to 25th. So we know what's going to hit us today, because we're going into 28th now. So this is what we can expect, the energy that's going to hit today. Oh, no, this event. Oh, that's right. The beginning of this slow motion event. The energy from the beginning of this slow motion event that we were reporting comes in today. It's going, all right, there's a blast that goes past it right as it first comes out. Watch. Boom. That one is going to come. This thing is going to, the actual object will pass probably 7 days later, because it is going so slow. That is going to slow up our storm. I believe that the slow motion of this object might hold up this storm today here. It might not move out as fast. It might stall and really kind of hook up more. I got a really sick feeling in my stomach right now. I might have to take a break. I think we covered pretty much everything too, didn't we? Boy. Oh boy. That's why I wanted to drop what I was doing to go see Dutch's report. I wanted you guys to go over there too and see his report and versus mine. Okay. And we, like I said, we agree on a lot of stuff. All right. I think if he understood how the core works a little bit better, he would understand the what's really going on here. Okay. He has a lot of doubt in this site, you know what I'm saying, and in others sites that report, okay, and so do I, okay, for good reason. All right, I agree with him on that. All right, these numbers that we're getting right here, these are numbers, but we know that they have the potential to be a lot higher. Let's just say they would never increase them, would they? But they would decrease them, right? And if they decreased them and it's still popping off at 6.6 at a depth of 598, and they decreased that, and they decreased the 6.0 that started it all, and the 6.6 and all the 5.5s and 4.4s, if all of those have been decreased, we're in deep shit. And if they haven't been decreased, we're in deep shit. Either way, this right here is deep Okay? That's why I'm using that term. I try not to cuss. This new side of me's come out, and I don't know why. Because I think because I'm finally had enough. Fair warning for this whole region and anywhere up the chain. Okay? It is so quiet up the chain. It pushed so much energy up here, it could snap anywhere. Most logical first place I would expect maybe apex point up here going down, definitely going into the system right here at the very tip of the fault. Can I see the fault? Oh my god, this colorization is just, I'm gonna pull my hair out. Wait, I already did. Okay, you see this fault, how it comes off of Fiji. It starts this hook pattern. It's following the contour, the ocean floor, right? These apex points, these bends and curves in the plates where energy flows and then has to change direction. It's going to drop off quakes. These apex points, maybe anywhere along the line now. With this much energy, it could be anywhere on the system. And as we go up, this quietness is very, very alarming. All right. It's locked and just ready to fire. All of these little quakes here all happened prior. Yes. Except for this one. They all happened prior to the big flurry of earthquakes. Let me check that one again. 13. Yeah, that one happened. This is just an independent quake that happened on its own after the big series because it's way up here. It's part of that 4.5 energy that was flowing up. Locked and loaded. I'm telling you guys, the potential is there. If it doesn't squeak out here, it could just come all the way over and bingo right here. Oh man, what's the opposite side of the planet from this? Oh, where's my globe? I have been fighting for over 500 hours now, so I am at a loss for what the term is called. I know what it's called. It's the opposite pole, the opposite side of the planet, the opposite side of this quake. Somebody help me with the term if you know what I'm talking about. I know what it's called. I can't think of it right now. I have 70,000 thoughts per second. It's just prayers and people screaming and all kinds of great stuff while trying to focus on this. Anyway, Dutch is always talking how big quake like this can always trigger something on the opposite side of the planet from this. So we should be watching that spot as well. The whole system now has just been lit up, all right? There is way too much energy out there coming to the surface right at the mouth of the system. Okay, it's going to enter this and just start heading up. It is also going to travel south and ring the bells in Christchurch, probably. Probably, I'd say 7.5 to an 8.0 here in New Zealand, probably in the next couple hours. Okay? This is a heads up right now for the island of New Zealand. You guys got energy on a scale, a very disturbing scale. Dutch talks about the catcher's mitt right here. It could happen there. This North Island seems to be a weak spot where they've already had a 4.2 scrubbing off energy, right? So it could happen right here. This island is, let's just kind of get into the fault of this island. Can you see how it running down right here and then cuts right across the north part of the island, right? Kind of cuts that whole thing in two and then runs down the coast here. Oh, went too deep and we lose it. Can you see it running down the coast there? Follow my mouse right here. That's the freaking fault. It runs down the coast of this island. They're going to have a pretty good sized quake coming in. And it's going to strike. I hope it's not a very populated centered place, but you see this little apex point right here, this little bend right here? It could fire off right here. You have an 8.0, 8.5 right here. It could send a tsunami right into New Zealand. Okay, I'm not trying to scare you. I am trying to talk soberly to you guys. All right, as soberly as I can without screaming into this microphone and pulling my hair out. Yeah. So I'm gonna be conservative with this because I don't want to go scaring everybody. 9.0 to 9.7 energy coming up at the surface in this area. Down here, possible 8.5 to 9.0 quake. Up here, possible 9.0 tsunami, possible 9.0. Then as it splits and goes up the system here, it's gonna travel over this and go over here right towards this island. This energy is gonna come up here, dropping off big quakes along the line. It'll set off the volcanoes over here in Java. Probably volcano right here. And Krakatoa will probably go off, I would say, within the next day and a half. Probably right around there. I don't know. What do you guys think? Does that sound crazy? Do I sound too far out of line? Because it's already exploded just a couple weeks ago, and it's already going. So we just added how much more energy to the system? As if we don't have enough volcanoes and stuff going off right now, and enough sulfur dioxide in our air already. This series of quakes is really going to screw stuff up for us. And I use that term gently. I'd rather you drop the big F-bomb. But there was a quake right over here, okay? It did come up. I was talking about the other day. It did travel up. It dropped off quakes along the line. There was a quake over here, right off the apex. I thought it might bend around and make it around this, but it did. It dropped off one over here. We could go, where is it, to the other, all 7 days, but it's already off the map. Trust me, there was one right here. It was about the same size as this one right here, a 5.2. So that's that 5-point energy. Remember I was telling you it was going to come up the system. The 5.1s that were going to drop off here. It bent the corner. Here's the 5.2. It entered over here. It's scrubbing off energy as it comes in. 4.9 at Iran. You know, I came up here and dumped a 4.2. 4.1. Okay, so that's the energy that made it around the corner. It got spilled out this way. All right, now they have a whole new round. You're going to see all this chain just light up here pretty soon with healthy sized earthquakes. If we don't have a big one in this area, you are going to see a bunch of healthy sized earthquakes dropped off along the whole chain. Okay, if we don't see a major volcano go off right around here and relieve a lot of the pressure that just came up from down below, the pressure that just came up from down below has to be released somewhere. We need the island of Fiji to, pop off a volcano or something like that to relieve the pressure. If nothing does, it's just going to creep. And it's going to find a weakness. And wherever the weakness part is, it's just going to pop off the biggest quake. I pray I'm wrong. I pray that this just all shuffles out as a bunch of mid-range 5s and we can all breathe a sigh of relief. So that's what we need to pray for. and pray hard, because we got a monster of energy that has just been entered into the system. I mean, all of these added together, it might as well have been a freaking 8.5 at this depth. It would translate to a 9.5 at the surface. That's why I'm calling for like 9.0 to 9.7. Almost 10. I wouldn't be surprised if we saw 10 out of this. Bible talks about a great quake, right? We have Nemesis coming in. And Nibiru with all those moons and stuff will be here in about 3 days. So, in 3 days from now, whatever energy, if it hasn't popped off by then, will definitely pop off by 3 days from now in a way that will be huge in this area if we don't have any kind of release here soon. Okay? So, a 7.5 to 8.0 in this region would not be bad. It would scrub off a lot of energy in a region where it would do minimal damage, or at least not as much damage as it could, say, if it were downtown San Francisco or LA or something like that, right? Got to remember something else too about Dutch's channel. This is something my channel doesn't have, and I wish I had his little arrows that point across. You know how he points the arrow, energy goes straight across sometimes? It doesn't have to go all the way around the loop. Do you guys remember? It doesn't have to go enter the system and go all the way around the loop. It just moved the entire plate on a 7.5 to 8 point level. Wing! It could transfer immediately over to here. That's why the whole ring right now is on high alert, especially this area. Okay? This usually translates straight across to South America. But it could go anywhere, you guys. So please just be alert. Have a plan now. What are you going to do if tomorrow, there's a tsunami alert for the West Coast? Are you working on the West Coast? Do you work near the coast? What are your plans for tomorrow if all of a sudden there was a big quake in this area that set off a real tsunami? Not just an alert, a 30-foot wave that's going to, do a Japan type thing. Are you ready for that? And what are your plans for if that's going to happen tomorrow? Or the day after tomorrow, or by 3 days. You guys got 3 days until it does happen for sure. Right? You guys got 3 days until it happens for sure, right? It might happen before, but let's go to today. Or what was today, now yesterday. And Nemesis and all the objects and all the influence and the power of magnetic field that this system brings with it when it passes behind the Earth. And whatever this thing is, I don't really want to discuss what that is. Hopefully it's just another stellar core making a weird shape with the CME. But boy, it sure looks like something else, doesn't it, folks? And that's all due to interact with the Earth on the 30th. It says, look, and pull this down just a tad bit more, or maybe push it back a little bit more. There you go. So you can see the date. That's today, 4/27. Add 3 days for this to get here. That would be the 30th. I want to know what you think it is, Brother Brian. You want to know what I think? What is Nemesis? I know what it is. I think I told you already what it is. It's a black hole. It's a dead star system with a bunch of other dead stellar cores rotating around it. It's a vampiric dead star that sucks energy off of living stars, right? It's our binary twin. It's our, they see all these other solar systems that have binary, right? And then they look at ours and they go, well, we're odd. We're the only one that has a single star. Well, no, we're a binary. You just can't see the other star because it burned out and turned into a black hole. Okay? It fits the definition of many things. It fits the definition of a neutron star, a stellar core, a black hole. A black hole is not or trinary. Yes, there are trinary systems as well. A black hole is not a hole in the fabric of space-time like the bullshit that Hollywood taught you. All right? That is just an absolute lie. The term hole is very deceptive. It should be called a black sphere, not a black hole. It's a black sphere. It's a super dense stellar core that has so much mass it has more than 10 times or 5 times, the mass of the sun. That's the definition of a black hole. It's a stellar core that has more than 5 times the mass of our sun. Well, this one happens to have about 10 times the mass of our sun. That would classify it as a black hole. It doesn't reflect light. It is so massive and has so much matter, and it's all dark matter that has 0 electrons, 0 protons. It's struggling to extrapolate them from any other source that provides them, like the sun. That's why it magnetically latches onto the sun and rips off these protons, photons, electrons, trying to revive itself and burn again. But the core itself is bigger than our star. Our star can never provide enough power to jumpstart that thing. So it will eventually suck the sun dry. It will kill the sun. It might glow for a brief moment. At the moment that it does finally finish off our star, it might start to glow for a few moments, but it'll probably dim out because it just won't be enough to satisfy the size, the sheer mass of it. The core is 10 times bigger than our whole star. We don't stand a chance against it. So, unfortunately, that will be the demise of the sun eventually here soon. Right? And then what happens when the sun goes? Well, all of a sudden, we go. This thing is going to rock the earth as it passes by. I'd love to see those terms and definitions you showed us from your book in pics. Oh, you want to see that book again? I can pull it out really quick. We'll go over it real quick because this is just too dang important. And that was a request from a team member. That's not just anybody. That's somebody in the team here that wants to see. So we'll just kind of put this on hold for a second. Okay, I'm just going to do a few little adjustments so we can see the book, right? You guys want to see it? This is a very hard book to come by, too, and that's why I will show it to you guys. It's very special. And not everybody gets to have the knowledge that's in it. Well, everybody does. You just got to get the proper sources, right? You can't just take your information from just anybody, right? You got to have somebody that knows what they're doing, knows what they're talking about, right? So, wait, we're going to still leave the camera mounted here, though. All right, my bad. Hang on. I'm going to try something here. You guys are awesome for being so patient for the book. You want to see the page definitions, I'm sure you do, because that's the best part of this book. Oh, and it has all sorts of great pictures to it, but we'll get to that first. All right, let me... Come on, Lord, I want it just right. Oh, goody. All right. Okay, I think we're getting there. Now we're gonna have to move camera and do some other adjustments. So bear with me, class. Is it buggy when I call you guys class? I hope not, because this is a lot of learning in here, okay? So that's why I do that. It's not coming in the best. Anyways, we got all kinds of lighting issues. The dang pages are shiny themselves, so we're gonna have to just lean forward and we'll go through them kind of. Yep, just be patient. We're making adjustments. We're gonna get this. Hang on. I got a new tactic here. That's gonna go right there. Oh, you guys would laugh if you saw my hokey little setup I have to use with tripods and books and all sorts of stuff to balance a broken tripod that has has no clamp. You know what my clamp is to hold the camera, you guys? A table vise. A table vise that squeezed one part of the clamp onto the tripod, and the other part of the table vise jaws actually bite down on my phone. Yeah, super high tech, right? All right, well, we're just gonna keep working it until we get it here. I think we're gonna get closer and closer and closer and closer and closer and closer until we're dang near there. Ooh, we're getting there. Okay. Can I zoom in? No? Oh, wait. Oh my gosh, I just found out I could do that with my camera. No way. All right, there we go. You guys are seeing it right there. That's the definition of black hole. And oops, and I'll read it to you here in a second. Let me get it. Not so shiny. There we go. Okay, we got a couple of good ones here already right next to each other. So black hole, a super dense point in space formed by a collapsing stellar core more than 5 times the mass of the sun. A black hole's gravity is so powerful that even light cannot escape from it. Okay, you see what I'm reading right up here? So let's simplify that. A black hole is a super dense stellar core that's more than 5 times the mass of the sun. Black hole's gravity is so powerful that light cannot escape from it. That means light cannot reflect off of it. You get it? You can't see it because light cannot reflect off of it. It absorbs light. It's light deprived. It's sucking light from our sun. It's like a vampire. A lot of people want to call this a brown dwarf. It also fits the definition of brown dwarf. It's a failed star. It's a ball of gas that never grew big enough to start shining by nuclear fusion, but which still glows dimly in infrared. Okay? It did burn one time. It's a failed star. It was burning at one time. It's a failed star now. It does glow in infrared. Okay? But it's really hard because most of that infrared is being absorbed because it absorbs light. Okay? Where is a very important one? Core. Can you see core right here? Let's drop down the wedge. Take out around a wedge for you NASCAR fans. Sorry, I'm a big old NASCAR fan. I'm a redneck. Good old country boy, that's right. Your big buddy is a good old boy. Does that bring joy to your heart? Okay. Core is the central region of a star or a planet. Both a star or a planet. Planets and stars have cores. They are not hollow. The central region of a star or planet. In a star, the core is the region where temperatures and pressures are high enough to trigger nuclear fusion. Capiche? You understand? Not too tough, right? All right, now for my favorite. Now this one, you guys pay attention here to dark nebula, okay? A dark nebula is a cloud of interstellar gas or dust that absorbs light and is only visible when silhouetted against a cloud of stars or another type of nebula, okay? Now that sounds all confusing and what? So let's simplify it, all right? The part I want to simplify, dark nebula is a cloud of interstellar gas and dust. What is gas and dust? It's matter, isn't it? Gas and dust is matter. Dark nebula is a cloud of matter that absorbs light. It's matter that absorbs light and is only visible when silhouetted. Absorbs light, only visible when silhouetted. Absorbs light, only visible when silhouetted. Dark matter is real. It's not in the form of an atom. It's more in the form of a coagulant, something that has acquired, it's a condensate. It has condensed and condensated, much like water does, by attracting more and more into its gravitational field. The more it pulls in, the bigger it gets, the bigger its gravitational field gets, the more it sucks in, the bigger it gets, the more it sucks in, the bigger it gets, the more it sucks in, the bigger it gets, and it just keeps growing and growing and growing. That's all it does, is eat stars and grow. It chews them up, spits them out, and spits out the core, right? It sucks all the energy right out of it and leaves a lifeless, dead core in its wake. And all these cores are following along the main big one, right? You getting this now? Seeing what's going on? You're starting to understand how this stuff works, right? Where is another important one here before we close up the book? Question. Somebody pick one out and we'll read it while we got it here. Or if you see one in there that you want me to read. Pulsar. Here's another important one. Okay. Why is it not picking it up? Oh. Okay, we need to come over just a little bit more here. Alright. Our pulsar. Can you see it? Get the light just a little bit better. Please, Lord, let it work. Alright, there we are, right up here. Where'd it go? Right above radio. Right here. Pulsar. A rapidly spinning neutron star with an intense magnetic field that channels its radiation out along two narrow beams that sweep across the sky. Okay, you've all seen the pulsar with the spinning little beams coming out of it. Where is neutron star? There it is down here. You see that one on the screen? Oh, it's just below the horizon here. Okay, let me drop another round of wedge. Okay, this also fits this description. Our object fits this description almost the best. Okay. Wait, it's not all in there. Help, Dad. What do we do? Yes, sir. We do it that way. I get your motives. Pretty easy when you just listen. All right, neutron star. Where we go? The collapsed core of a heavyweight star left behind by a supernova explosion. A neutron star is the densest known object. Though in the most massive stars, the core can collapse past the neutron star stage into a black hole. Many neutron stars are also pulsars. Well, many neutron stars are also black holes. Okay? So, it's the core. It's a core. Oops. It's a core. It's the core of a neutron star. It was a heavyweight star. It's the collapsed core of a heavyweight star that's left over behind a supernova explosion. So it probably had a supernova explosion that affected this planet a long time ago, or the planets around it, stripping them, causing them to be cores, right? Okay, thus it has this already core on core effect, right? The brown dwarf here up here, the brown dwarf definition: a failed star, a ball of gas. This one grew big enough. This one it says a ball of gas that never grew big enough to start burning. Our object was already burning. It failed. It's a failed star. So a lot of people want to call it a brown dwarf, but it's not really a brown dwarf. It is a failed star, but it's not a full-on brown dwarf. It's not a ball of gas. It's a ball of iron. It's a ball of black. It's a ball of dark matter is what it is. It's a giant sphere of dark matter. And dark matter has different properties than regular matter. Even though it's so massive, it doesn't have the same gravity that a mass that big would have. It's missing a lot of weight from electrons, photons, and protons. All that weight is missing from each atom, right? So even though it's massive and it has a lot of density, it is still lighter than normal material because it's lacking those parts of the element. Okay? I'm glad you guys are getting this stuff. You guys are awesome. I love you guys. I can hear every one of you guys, little light bulbs going off over your head. Wow, I get it. Wow, that's cool. Dang, now it makes sense. You guys are awesome. I love you guys. Now where do you want to go, class? Because that was basically all the good stuff out of the book that we need for the moment. Actually, while we got this here, there are a couple of pages. Where's the one on the sun? Oh, wait a second here, because there's a couple of examples I want to use for our display. We have the core of the sun in this book, and I want to show you what the core of the sun looks like. You guys want to see what the core of the sun looks like? All right. Let's pull back out of this full-on zoom. Whoa. Easy, teacher. Is that as far zoomed out as we go? I guess so. Oh, that's right, because we're so far zoomed in and all this great stuff. Okay, so what I'm going to do, first get our lighting just about right. Okay. Boom, 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 boom. Oh, that's not working. There we go. Okay, you can see there's a core. There's a radioactive zone. There's the connective zone. And then there's the photosphere. Okay? Now, the core has a shell around it, much like the Earth's does. That core spinning in the shell, that gyro effect, is what causes the corona of the sun to glow, the photosphere. That photosphere is caused by the core rotating inside the shell, just like the Earth produces its electromagnetic field. This is an electromagnetic field, just on a grander scale. Okay, that's all that it is. It's the same mechanism. It's the same gyro mechanism. Did I just lose you guys? All right, who's throwing paper airplanes? All right, back to class. The core spins inside its shell, creating the electromagnetic field that produces the photosphere. Okay, the corona. That's why the sun shines, because the core is spinning inside of a shell. All right, it's that simple. It's the same effect on the Earth. Where was it? One I want to use for Earth. Come back here, you. Bear with me. We are getting there. Oh, I guess it was before. Mercury. Why would you do backwards? Venus, then the Earth, right? No, Venus and Mercury. Then the Sun, or you turkeys. And then Mars. And then Jupiter. See? They forgot about the Earth. Oh, that's right. This book was written when the Earth was missing. What? The Earth was missing? There was a time when the Earth wasn't here? Alright. Get up and come on over. Do you see the core? Do you see the shell? Here, I gotta hold a 10-pound camera. I got it. You can see our core, the shell going around it, that white zone. The boundary, that boundary, right where that shell and that core meet is where the grinding happens, okay? That's where our Schumann grinding comes from, is right at that boundary. That core spinning inside that shell freely creates the electromagnetic field around the outside of the planet that's our shield. Ta-da! Okay? Then you can see we have core, we have shell, then we have magma. Then we have crust. That is solidified magma that is cooled on the outside of the planet, right? That crust is a layer. It holds all the pressure in. So when that core tries to expand outward into the shell wants to expand outward into the magma. The magma wants to expand outward into the crust, but it can't because the crust is holding it in there. The magma builds up pressure, which pushes back down onto the shell. The shell can't expand outward. It can only expand down inward onto the core. So when the core expands, the shell expands back down on it, creating our screeching effect. Capisce? Catorce? Comprende? Congratulations. You all get an A. And get ready to see storms like that, okay? They're going to be very, very photogenic, very symmetrical. They're going to be very powerful, concentrated storms now, like that, because of our newfound buddy in the neighborhood. Okay, so that's the book for tonight. Good idea, class. Good idea. Oh, what's this? What's going on here? What's going on here? Oh, that's my class. Hi, guys. Oh, you all so excited about tonight's show. I can tell. Yes, indeedy. Some are excited, others are disgusted. But that's kind of my little audience. It kind of represents you guys. Keep me motivated when you're not here in my chat. So pick out which one you would be. And it's funny because I got the cutouts from the back of the cereal box. It's all one big face. And I'll stick them behind a door and surprise people with them. Yeah, so don't be surprised if you go into the bathroom at some Walmart and you see this big, funny, smiling face looking back at you. Because I'm a joker. I like to pull fun stuff, too. Alright, I think there's a cute one for the ladies right there. That's some of the gals in our audience right there. Is that little one right there. And sometimes I'm feeling like that, dude. Alright, just having fun with you guys. Alright, class, you guys are awesome. I love you. It's getting late. I've kept the entire household up way too late, so till the next video, hang in there. I'm gonna have to do an update here pretty soon if instruments change. If we have this big quake in the middle of the night, I might be back. Love you all. Bye.